to Maheshwari chemistry classes. Today our topic is a senior intermediate, very important VSAQs. Already you have an idea about the LAQs and SAQs. Previous video once you have to check, but VSAQs purpose most of the students have doubt. That is why here I am explaining. So listen properly better and please give me your support. I don't want to waste your time. So please subscribe my channel and like this video, share with your friends. Listen properly. Where the important is there, that time I can explain more, and normal questions purpose I can explain in light way. So listen properly. First question, why Zn2 plus is diamagnetic whereas Mn2 plus is paramagnetic? Okay, it is from D block elements. Okay, so in this Zn2 plus is diamagnetic. Why? Because electronic configuration is argon 4s0 3d10. In this, if you write 3d10, 5 d orbital 5 subshells filled with the 2 electrons. Here there is no single electron, right? So you have to check this. No single electron, no unpaired electrons in a Zn2 plus. But if you take this Mn2 plus electronic configuration, it contains argon 4s0 3d5. Here d5 is there. Okay, so means first we have to fill with the 1 electron. If extra electrons are there, then we have to start the pairing, right? So here single electrons are 5 single electrons are present in Mn2 plus, but Zn2 plus no single electrons, all are fulfilled with the 2 electrons. Mn2 plus single electrons are present. Where single electrons are present, there magnetic property present, at the same time color property present. It exhibit the magnetic nature and color property. Remember, Zn2 plus diamagnetic, no unpaired electrons, means no single electrons in Zn2 plus, but Mn2 plus single electrons are 5, that is why it is paramagnetic. Okay, simple. This is the trick. Single electron present, magnetic property present. Next, aqueous copper 2 plus ions are exhibit blue color, whereas aqueous Zn2 plus are colorless. Why? Same as this is also same reason. Copper 2 plus purpose electronic configuration argon 4s0 3d9. So if you write this electronic configuration according to that, if you fill the electrons, only one electron is present, single electron, only one single electron is present in copper 2 plus, that is why it exhibit blue color. But if you take the Zn2 plus purpose, here fully filled 3d10 is there. So in previous question once you check there, like this same as this here also. Okay, that is why no unpaired electrons in Zn2 plus. Unpaired electrons absent means, okay, means single electron. Unpaired nothing but a single electron. Okay, if the single electron is absent, then it is dia. Okay, at the same time no color property. In copper 2 plus single electron present, that is why color exhibited. In Mn2 plus single electrons are present, that is why magnetic property present. But in Zn2 plus no single electron present, that is why it is diamagnetic and it is a colorless compound. Okay, next, these two are very important. Okay, next, one more question from the D block elements. Write the characteristic properties of the transition elements. Okay, so transition elements shows variable oxidation states, paramagnetic character, complex compounds, colored hydrated ions and salts, catalytic activity and alloys are formed. Okay, simple beta. Different oxidation states are present, that is nothing but variable oxidation state. Paramagnetic character, why? Because single electrons are present. Complex compounds are present. It exhibits the complex compound nature for the stability purpose. Okay, next, hydrated ions and salts also exhibit the color in where transition elements. All these are the transition element characteristics, nothing but properties also. Okay, so catalytic activity also present. Okay, so next, alloy nature, nothing but mixture of metals. Okay, next question, what is ambident ligand? Give an example. It is very important question. Okay, so at the same time easy also. Once you check this, ambident ligand. Okay, actually here a unident ligand contain 2 possible donor atoms, can coordinate through either of donor atoms. Such type of ligands called as ambident ligand. For example, cyanide Cn minus and nitro NO2 minus. Okay, ambi means both condition. Simple, you have to check this trick. One ligand but 2 donors are ready. Okay, only one ligand. If you take nitro NO2, only one of the ligand it is. Okay, but here 2 possibility impurities, 2 donor atoms are there. For example, in the NO2, sometimes N is the donor, electron donor, sometimes oxygen is the donor. ONO condition, oxygen donor, NO2 condition, nitrogen donor. Okay, so 2 donor sites are ready in a single ligand. Okay, so this is known as ambident ligand. Okay, next cyanide also, actually CN is there. Okay, CN, cyanide condition, carbon nitrogen donor. Here at the same time NC, here a nitrogen donor and carbon donor. Cyanide, carbon donor, and isocyanide NC, nitrogen donor. Okay, 2 donor sites are present in a single ligand. 2 donor sites in a single ligand. This is known as a ambident ligand. Example, nitrocyano. Important question. Next, one more important VSAQ, that is what is Ziegler-Natta catalyst and it is uses okay, titanium tetrachloride and triethyl aluminum is known as a Ziegler-Natta catalyst. Actually another formula is also there, like this: titanium tetrahalide and trialkyl aluminum. Okay, so MSET purpose also it is useful. Important bit, R nothing but alkyl group, here X nothing but halogen atoms. 4 halogen atoms are combined with the titanium and 3 alkyl groups are attached with the aluminum. Okay, these combination. Okay, tetrahalide titanium and trialkyl aluminum. Here what I had taken TiCl4 according to the intermediate second year syllabus. TiCl4 and AlCH3 taken 3 is there. Titanium tetrachloride and trimethyl aluminum. Okay, so this is known as Ziegler-Natta catalyst. Where it is uses is especially for the polyethylene preparation purpose. Ethylene in presence of the Ziegler-Natta catalyst, it will give the HDPE, high density polyethylene. Okay, this is the use of Ziegler-Natta catalyst. It is very important question. You have to check this reaction also. Okay, next question, what is biodegradable polymer, and give one example. This is also important, very important VSAQ. The polymer easily degrade in presence of sunlight and water and microorganism is called biodegradable polymer. Okay, so especially easily destroyed polymer in presence of sunlight and water and microorganism. Example is PHBV. Okay, PHBV full form, what is that beta? They will ask this combination as a SAQ also, PHBV. And one more biodegradable polymer example is a polyester acid. First of all, PHBV also one of the important VSAQ. Either sometimes combinationally they will give as a SAQ. Once you check this, what is PHBV? PHBV how it is useful to the man. Okay, so PHBV means polybeta hydroxybutyrate and co-beta hydroxyvalerate. It is a biodegradable polymer and it is a copolymer. Here butyrate purpose 4 carbons, here valerate purpose 5 carbons containing 8 Okay, here COOH group when lost the water molecules, it is a copolymer especially. Okay, poly beta hydroxybutyrate. Okay, PHBV. Okay, P means poly, beta hydroxy H, butyrate B, and co beta hydroxy V means valerate. Okay, so this is the biodegradable polymer and PHBV uses. It is useful for the manufacture of capsules. Okay, sometimes when we saw the capsules, I mean tablets, they will coated like cover like tablets are there, especially gas trouble related tablets or vitamin tablets are it is looking like a plastic cover inside tablet, not I am telling outside sheet. Inside the tablet it is a capsule type is there, like these. Okay, especially gas tablets, if you check these, you may easily understood. Okay, and this tablet outside is just look like a plastic cover. Okay, that is a polymer. Which polymer? This biodegradable polymer. Okay, and it is easily destroyed when we taken this tablet inside, and when it is mingled with the water, it is easily melt. Okay, so this is a PHBV use. And one more important, packing of orthopedic devices packing purpose also it is useful. What is that beta? PHBV. Next, what is vulcanization of rubber? Okay, it is the process of heating of raw rubber, nothing but natural rubber, with sulfur at 373 to 415 Kelvin to improve its physical properties. Okay, natural rubber, nothing but raw rubber, nothing but impurities containing rubber, physical properties improving purpose, we have to add the sulfur. Okay, what we have to add? Important, sulfur we have to add. Okay, in presence of how much the temperature? 373 to 415 Kelvin. Okay, so that process is known as vulcanization of rubber. This natural rubber added with the sulfur in presence of 373 to 415 Kelvin temperature. It improves the physical properties of natural rubber. That's it. Okay, it is also very very important VSAQ. We may expect this type of questions. Please subscribe my channel Maheshwari Chemistry Classes and listen carefully. Next question, what is primary battery? The battery which is useful for the single usage. Okay, just like our olden days wristwatches and battery watches, radio watches, battery purpose, what is that, radio purpose utilizing that battery, single usage batteries. Okay, so it can work limited period. Okay, for example, dry cell. Next, what is the secondary cell? It is the charging discharging, both phenomena are present. Only discharging is present in the primary battery, charging discharging both present in the secondary battery. Best example, our cell phone containing battery. Okay, next, these are not that much important, that is why I told. Firstly, next, explain polling. Okay, what is polling? Molten metal is covered with the carbon powder and stirred with the green wood log. That is nothing but pole. It released hydrogen gases to reduce the oxide impurities. Okay, especially copper and stannum metals refining purpose. We are using these polling technique. That is why example, what is it beta? Copper stannum refined metal is a polling metal. In this process especially, you have to imagine, it may be mesmerized in a container. You have to imagine in this molten metal is present, not in solid form, melted condition, just like you have to imagine melted chocolate. Okay, that that kind of a molten metal, it is added with the copper powder. This copper powder is stirred with the green wood log, nothing but freshly cutted wood log. Okay, so this wood log releases the hydrogen gas. This wood log releases the hydrogen gas towards the molten metal side. It reduces the oxide impurities. Nothing but automatically the metal is purified. Okay, so which metal beta? Copper and stannum metals. It is also important VSAQ. Next, one more. What is the role of cryolite in the metallurgy of aluminum? Why we are using cryolite, especially metallurgy, aluminum? Okay, aluminum extraction purpose, how it is useful. Okay, cryolite increases the conductivity of alumina. Okay, conductivity increases, important bit. Conductivity increases. Conductivity nothing but a flow of electrons. Here conducting nature is increases when we add the cryolite. Okay, next when we add the cryolite, it decreases the melting point of the malt, especially starting time. Approximate purpose I am telling, understanding purpose. Okay, for example, it may be starting time 2000 degree Kelvin is required for the melting condition purpose, but when we add the cryolite, automatically it decreased only 1000 degrees Celsius, means automatically 1000 degrees Kelvin is 1000 degree Kelvin is a decrease. Nothing but manufacturing purpose, nothing but this ore purification purpose. Okay, so expenditure is decreased. Okay, so this way we can utilize this cryolite. Simple, cryolite increases the conductivity of alumina and it decreases the melting point of the malt. How much? 2323 K to 1140 K. ఓకే, బెటర్ నాకు ఎడిట్ చేయడానికి టైం లేదు. ఈ వీడియో ఎట్లా వస్తే అట్లా అప్లోడ్ చేస్తాం, మీకు కూడా తెలుసు. దిస్ ఇస్ ద క్రూషియల్ టైం, సో లిజన్ కేర్ఫుల్లీ. నెక్స్ట్, what is allotropy? Explain different allotropic forms of phosphorus. Some elements are shows different physical properties and same chemical properties is called the allotropy. Already you have an idea about the carbon. In 10th class also you learn this. In first year also you have an idea about this allotropic nature. Physical properties are different, but chemical formula is same. For example, white and yellow phosphorus purpose formula is P only, but it appears in white and yellow color. Red phosphorus purpose also formula P, I mean phosphorus molecular formula P only, but it is in red color. Appearance is different, physical appearance is different, but chemical formula is same, chemical properties are same. Alpha black phosphorus. Okay, so these are the allotropic forms. Examples: allotropy means physical properties are different but chemical properties are same. Okay, so that is known as allotropy. Allotropy of phosphorus purpose examples: white, red, black phosphorus. Okay, it is also important VSAQ. Next, one more important question. What is an inert pair effect? Most of the students have doubt about this inert pair effect and interhalogen compounds. That is why both I wrote at a time. Okay, listen properly and check this question. What is inert pair effect? Okay, especially the reluctance of ns pair electrons to take part in bond formation is called inert pair effect. Simple beta, in bond forming ns electrons are not involved. That's it. Okay, ns ఆర్బిటల్లో ఉండే ఎలక్ట్రాన్లు రెండు ఉంటాయి, ఇవి న్యూక్లియస్కి దగ్గరకు ఉంటాయి కాబట్టి అసలు బాండ్ ఫామ్ అవడంలో ఇవి ఇన్వాల్వ్ కావు. ఓకేనా, ఈ ఎస్ ఆర్బిటాల్ బాండ్ ఫార్మింగ్లో ఇన్వాల్వ్ కాకపోవడంని inert pair effect अंटार. ओके, सिंपल बेटा सुनो अरबिक बेटा. इनर्ट पेयर इफेक्ट बोले तो NS इलेक्ट्रॉन्स आर नॉट इन्वॉल्वड इन बॉन्ड फॉर्मिंग. इसको क्या बोलते हैं? इनर्ट पेयर इफेक्ट बोलते. కమెంట్లో అడిగారు హిందీ ఇంగ్లీష్ తెలుగులో ఎందుకు చెప్తున్నారంటే నా క్లాస్లో 3 టైప్స్ ఆఫ్ స్టూడెంట్స్ ఉన్నారండి, అందుకే ఇలా చెప్తున్నాను. నెక్స్ట్, వాట్ ఆర్ ఇంటర్ హాలోజన్ కాంపౌండ్స్? గివ్ 2 ఎగ్జాంపుల్స్. హాలోజన్స్ ఆర్ రియాక్ట్ విత్ అదర్ హాలోజన్స్ అండ్ గివ్ ద డిఫరెంట్ హాలోజన్ కంటైనింగ్ దట్ నోన్ యాజ్ ఇంటర్ హాలోజన్ కాంపౌండ్స్. సింపుల్. హియర్ one compound purpose, compounds nothing but atoms are combined to give a compound. Here two are the in this compound involving atoms are different types of atoms are there, but those two are the halogens only. Different halogen atoms are involved in the interhalogen compound formation purpose. For example, if you take a IF7, here iodine also halogen, fluorine also halogen, but it is a compound. Okay, halogen compound, interhalogen, different type of halogens are combined to give a compound. This is a interhalogen compound. Understood? IF7, here iodine 1 and fluorine 7, and it will give the iodine heptafluoride. Okay, here chloride fluoride, so ClF. Okay, here chlorine is also halogen and fluorine also halogen. It is a interhalogen compound. Interhalogen compound means two types of different halogens are different types of halogen atoms are combined to give a interhalogen compound. Inert pair effect means ns electrons are not involved in the bond formation. That's it. Okay, these are also important VSAQs. Next, define molarity with units. Simple. 1 liter of solution containing moles number is known as a molarity. Okay, the number of moles of solute dissolved in 1 liter of solution is called molarity, and its units are moles per liter. Molarity purpose, number of moles of solute by V in 1 liter. Okay, V nothing but volume in 1 liter. So if you take this M equals to N by V, moles number N, volume V. If you write this moles number purpose, moles number N equals to weight by gram molecular weight, right? So gram molecular weight by gram molecular weight, in the place of N here I wrote weight by gram molecular weight into 1000 by V. Okay, this is the molarity formula. Once again check beta, molarity equals weight by gram molecular weight into 1000 by V in ml. Next, define mole fraction, the ratio of number of moles of the one component of the solution to the total number of moles of all the components in the solution. Simple, one component moles number by total compounds moles number. This ratio is known as mole fraction. If you take solute purpose, here you have to take solute. If you take a solvent purpose, here you have to write a solvent. That's it. Okay, next, one more important question, define osmotic pressure. Osmosis is a process prevention purpose applying pressure. Okay, so simple beta. Okay, sorry, I can explain remaining questions in next video. Already it is too late, so please like this video and subscribe my channel. Next questions I can upload in next video. Please give me your support. Please compulsory you have to check this. It is compulsory useful to you. Thank you.